everybody, welcome to the 13th edition of the PC Perspective Mailbag. We've got a handful of questions here. Might be shorter than normal. We'll see how this goes. I tend to say that every time, but you get what you get. If you have a question for us, leave it in the comments section on the YouTube video or leave it in the comments on the post on PCPer.com. Either way, we'll be able to find them, go through them, and pick out a handful each week to answer in somewhat relatively accurate manner. Let's jump into it. Peanuts Revenge, which is a great name, wants to know, given that the ATX standard was conceived when system power draw was less than 300 watts and graphics cards were barely a thing, and now with Crosspoint poised to replace system memory soon, do you think it's time for a new standard? If so, how long before the required companies get together to make that happen? A couple of things on this. One, I don't think Crosspoint is going to replace system memory anytime soon. For consumers, right, it will be a supplement in the enterprise 100%. But I think replacing in the consumer side is probably a bit adventurous on your part of an assumption to make. The other thing I would keep in mind is all these changes, all these new standards and stuff, it's already taking place, right? Keep in mind that the desktop PC is not a growing space. It's not shrinking and declining as much as a lot of people would want to say, but it's also not like growing. So the need to somehow come up with a new standard or figure out a way to make this better is really minimal, right? Because the players that are in this field, the consumers that are building PCs, seem pretty comfortable with where they're at. Where that change is already occurring is in your mobile devices, your laptops, your two-in-ones, your convertibles. Then think of your all-in-one PCs like the MacBooks and, or not the MacBooks, the iMacs and all that type of stuff, the HPs, the Dells that do all these all-in-ones. All the form factor innovation is happening there. And you see a lot of stuff moved around, right? That's where you get MXM modules. That's where you get soldered on memory. Things that make changes to the form factor. Now, there's no real standard around them, which I think you could take as a negative, but it is changing and it's adapting to the changes to the technology as they go. So I don't expect I don't expect there to be like Intel and AMD and Asus and the power supply guys and the motherboard guys and the case guys coming together and go, we're going to create something new for this. I think it will be a slow evolution of things, if it happens at all, in the desktop field. Nebu Thomas wants to know, will running a 64-bit version of Windows improve gaming performance compared to a 32-bit version? In general, no, but you will run into some compatibility issues between that. There are some games that will only run on the 64-bit versions. I want to say Battlefield is one of those games now. I think when Battlefield was first shipping, it was actually a combinate, like you could run either the 64-bit or the 32-bit executable. As it sits now, as a PC user, there's really no need to run the 32-bit version of the operating system. In fact, I can't remember the last time I would have installed the 32-bit version of Windows 10 on anything for that matter. I don't think you inherently get any advantage. Like, the advantages of 64-bit again are addressing more memory, and that in theory, if you need more system memory, could do that. But I don't think there's any inherent gaming performance advantages to that. So just install 64-bit, man. It's fine. It's time. 64-bit's been around for a really long time. We've got this figured out. John STF72 wants to know, do you think Microsoft will make another operating system after Windows 10, or will they just keep updating it? I think eventually they'll move the number up to 11 or 12 or X or whatever else they're going to do. Will it matter as much? I don't think so. I think the iterative releases that we have seen Windows 10 take will kind of be the norm. We saw this on OS, Mac OS, OS 10, whatever they call it now. Like they do evolutions and they have new version numbers and new names for these operating systems, but they don't fundamentally change a whole lot. They just kind of wait until there's enough new features to package up and release that way. Microsoft still somewhat depends on operating system licensing for the majority of its income. Most of that comes from OEMs, not DIY consumers who are building PCs. but I still think they don't want to continue to let the Windows 10 license you have be good for updates into perpetuity. It would just not be good for their bottom line. So there will be some update at some point. I don't think it will be as quick as 8 to 10, but it'll happen, and it probably won't mean that much at the time, except they'll gate certain things behind it like they've done with every Windows release in recent memory. So BeatWolf44 wants to know, SLI and CrossFire, what do you think can be done to save or better implement them? Probably nothing at this point. The issue with SLI and CrossFire is as we moved to these lower level APIs like DirectX 12 and Vulkan, they put more. They give more power to the game developer / engine developer. As a result, the driver level control over some things is reduced or eliminated. And multi-GPU is one of those types of things. It became way, way, way more complex to try to provide an avenue for game developers and engine developers to easily access multiple GPUs of these APIs. So they decided that this was going to be on them now. Now, what I'm curious to see is, so we still have two-way SLI, two-way CrossFire support on the latest architectures, but that's only on DX11 or earlier titles. So I'm kind of curious to see what happens in the next year. Will game engines adopt and utilize and kind of embrace multiple graphics chips for their rendering, right? The holy grail has always been that, hey, you could have two from different generations, or one AMD and one NVIDIA, and it'd be able to work. And in theory, all of that is possible. They just have to actually implement it to do it. And we haven't seen a whole lot of drive from game developers or software developers across the board to really get that done. And it's not something like NVIDIA and AMD can go to these guys and offer suggestions and maybe provide, it might be something you see added to GameWorks or VRWorks, more specific ways for them to take advantage of multi-GPU. But then you get into vendor A versus vendor B's implementation, and does one hurt the other, and all that type of stuff. All that same problem would exist. So I'm not real bullish on the idea that SLI and CrossFire are going to make a big run, but I don't know. I like to see it. I still think that the interest is there and the power is there and the performance, the potential performance improvements are pretty impressive. But as it is now, you can't find one GPU for sale for the price you want to buy it at, so probably don't want to buy two. Trolling for Dollars asks, could you explain the process on how a wafer from the fab ends up in my hands as a CPU or a GPU? That's an incredibly complex question and topic that I feel like Josh addresses once every quarter in our podcast with some 20-minute explanation of what is actually happening. I'll give you the Cliff Notes version of what happens, right? So once the wafer is produced, all of the chips, all of the processor dies or whatever they happen to be are tested and validated, and then they are just basically cut out of that. They are packaged, which means you put the die onto a substrate, connect the pinouts to the correct locations, and then if it's a processor, that gets put into a box and shipped out. If it's a video card or something else, it gets put onto a PCB paired with memory. If it's a HBM2 graphics card like Vega, that die goes to another facility that mates it with a interposer that has HBM memory on it, and then that interposer is put onto a substrate that is then put onto a PCB, which is then put into a box, which is then shipped across the ocean to Newegg or Amazon distribution centers, and then you use your credit card and purchase it, and it shows up. It's pretty magical when you think about all the stuff that has to happen. I would say in general that's probably a 3 to 4 week process from the wafer being produced to a boxed product showing up. There are exceptions where they're trying to rush things along. You may be like a 2 week process, but that's pretty much a stretch. 3 to 4 weeks is probably a good idea, and then it all depends on what are you shipping by boat or are you shipping by plane, and that can make a pretty big difference as well as the stuff comes over from Taiwan. Nick Kearney wants to know, I'm thinking of switching from Intel to AMD Ryzen. In your experience, how has the Ryzen platform matured since its launch, particularly in terms of gaming frame rates? Has AMD or game developers made progress from the disappointing numbers we saw at launch? So 2 things. I would say in my experience, the Ryzen platform has matured substantially from its launch. If you look at the first week or 2 of the Ryzen 7 launch back in March, I believe it was kind of a mess, right? We had motherboard issues, BIOS issues, significant performance differences between reviewer A, reviewer B, nobody really having an answer from the processor vendor to the motherboard vendor, knowing why those performance things there. That's all kind of been ironed out, right? The BIOSes are very stable. The feature set is very consistent across the platforms. Memory overclocking has been greatly increased and improved, which is actually a big benefit because the Ryzen platform gains more in terms of performance, particularly gaming performance, when your memory clock speed is higher. Right, so that's worth noting. They've done a great job with that, and that showed in the Threadripper launch because the Threadripper launch was very, very clean, very neat, no issues of stability or compatibility that really stood out to me in that area. In terms of your specific question of frame rates and gaming and those types of things, have game developers made any changes? There have been a handful, right? You've got Ashes, and now I'm going to blank on a couple of the Rise of the Tomb Raider did some updates. There was another game or two that did some updates to try to improve their engine performance for Ryzen platforms over what they were at launch. I do not believe that it has been a very widespread improvement. I haven't seen like the Unreal Engine come out and say we've made this one significant change to our engine that will improve scaling and performance and threadability for Ryzen processors. I haven't seen that come out from Microsoft either in terms of, hey, we've done these Windows patches and we feel like this is going to address the issue. So if you're looking at gaming and you're comparing Intel and Ryzen, especially if you're looking at 1080p gaming, Intel's still going to have the advantage there. And that hasn't changed enough for me to change my view on that. If you're gaming at 1440p, the advantage is lessened. If you're gaming at 4K, the advantage is lessened. So it starts to level out. But I still think, like the new 8700K Kaby Lake part is the fastest gaming processor. It's got the highest single-threaded clock speeds. It's got 6 cores, which is 6 cores and 12 threads, which is plenty for games. So even though Ryzen offers 8 cores, 16 threads, it's running at lower clock speeds, lower IPC. Even in an ideal world, I think it would still be at a slight disadvantage there. But it's close enough. Like it's relatively close. If you go look at our 8700K review, you'll see like in the 1080p gaming results, the 8700K is ahead, right? Generally across the board. In the gaming test. If you're gaming at 1440p, maybe even 3440 by 1440, those 21 by 9 ultra wide screens, then the difference is pretty small actually. I wouldn't tell anybody that if you buy an AMD Ryzen system, you're going to have a subpar or a bad gaming experience, right? I still think you're going to have a really good gaming experience. If you want peak maximum frame rates at those kind of more moderate resolutions, Intel's still going to be the better choice. Lou L asks, is there any way to get security updates when running Windows 7 with the Kaby Lake processor? I have old games that don't run on newer versions of Windows but love my Kaby Lake CPU. Am I putting myself at risk by not updating, or should I just cave and get a cheap Skylake CPU for this system? I don't know if there's a way to get security updates for Windows 7 on Kaby Lake. I would guess that there is, because I trust in the capability of the hive mind that is the internet and people who want to use older hardware on older software and vice versa. So there's probably a way to do it. It's probably not real simple, and it may cause you some other headaches in terms of other Windows services not working or something like that. Looks like I'm getting a link in real time. Yeah, Extreme Tech does have a story on unofficial patch unblocks Windows 7 and 8.1 updates from Kaby Lake and Ryzen. So there are ways to do it. It's an unofficial patch, but you can do it. I don't, he says you say you've got some old games that don't run on newer versions of Windows. So I guess, that's a reason to keep it up. So, I would say if you had a Skylake processor, handy, like already in your stable, I would just go ahead and use that and then maintain your security updates from there. Otherwise, I guess these unofficial patches will probably do the job. You are putting yourself at risk for stuff, but it's as long as you're careful and if these patches are kind of put out at a semi-regular cadence, that seems like it could be okay. I don't know. I'll be honest. I'm not I don't update my machine every Patch Tuesday on the pattern that I should, right? So I'm not going to be the one to sit here and criticize people who choose to not do that because they have some software or compatibility or other issue that they want to maintain it with. So it's a really stupid delineation that has been created, but I think that's the case in a lot of hardware software platforms these days, unfortunately, especially if you look at like Kaby Lake and chipsets and all that. Robert Galloway wants to know, why do CPU reviews only compare the new processor to the last generation or two? Why not go back several generations when comparing, since that's likely to be a more common upgrade path for most? It's a good question, Robert. Honestly, the reasoning is, there's two reasons. One is constantly updating benchmarks, adding new benchmarks, using new revisions of benchmarks means that previous data is not comparable, right? And which means that if you then want to go back and say you want to throw a 2600K or a 3770K into that review, you have to drag out that platform. You have to be able to install the latest OS to it with the latest patches, and you have to get the benchmarks running, and it's a tedious process. So, like from my point of view, we're in the boat that you're talking about, right? We tend to compare back to, I think our 8700K goes back to the 6700K in terms of performance, maybe the 6600K as well, and we kind of depend on this base level understanding of what Skylake was to Sandy Bridge or something like that, right? Which admittedly is not fair in some ways, right? Because you want to see the most data, but it's really just a time constraint, and I assume that's my reasoning, and I assume that's the case for most reviewers as well. There's also a problem of data presentation, right? When we have 15 processors that we're trying to present data for, and then suddenly we want to add 10 more from older generations and older architectures, it becomes pretty daunting as well to even get it to you in a way that visually makes sense. Not that it's impossible, but it's just again another kind of problem in time sync that we have to be aware of. So, Dark Wizzy wants to know, people say that Kaby Lake and Skylake X were not a response to Ryzen. I have said that. To what extent do you think Intel saw Ryzen's performance coming and was able to change its plans for these new CPUs? The public knew Ryzen was coming years ago. Yeah, so clearly Intel knew Ryzen was coming. They knew Threadripper was coming. What the difference here is, so if you're Intel, you're learning about Ryzen as we learn about Ryzen. They have very little pre-knowledge about it. I'm sure at the very end, the very last minute, they have a board partner that they can get a processor from and do early testing. But literally that may be days before launch or days before press gets parts. So what they're trying to do this whole time is, based on information that is released publicly, benchmarks that are shown publicly, can they dissect and estimate what the final performance of this product will be? Now, what AMD did with Ryzen was interesting in that they kept the final clock speeds a little bit hidden until the end, whether it was on purpose or because they were still trying to figure out how high they could go and still offer competitive yields. I think that's probably the case. So Intel maybe underestimated the performance of Ryzen 7 upon its first launch. Now, that being said, is Kaby Lake or Skylake X a response to Ryzen? I think these products were already going to exist. Like Kaby Lake was a product that they had developed, that was there, that they maybe were holding in reserve. Maybe they're like, well, we don't know if we're going to need this yet, and maybe we'll wait. but we've got it here in case we need it. And so what Ryzen's release might have done is said, okay, we're definitely going to use it, and or rather than release this in January, let's release this now in August, because let's pull it in to August, September, whatever it is, and make sure that we're more competitive more quickly. And that may be indicative or indicated by the fact that stock of the 8700K was hard to find, and all the Kaby Lake processors were pretty hard to find, which is very unusual for Intel launches. Skylake kind of had that, but it's still kind of unusual for Intel processors. And I think the same thing happened with Skylake. They had planned high core count HEDT products, but they just pulled them in. They just said, okay, let's not wait till early 2018, let's do mid to late 2017. And as a result, we had some, power issues, some stability issues, and motherboards, right, things like that. That's what happens when you pull in products, right? Outside of if you move them ahead of the schedule that you were expecting, you're going to find little issues that pop up there. So are they a response to AMD? I'd still kind of say they're not a response. They didn't go, oh my God, Ryzen's here, quick, create a 6-core die. That's just not how it works. But it was, okay, let's take that thing, let's move it forward, and let's get back in the swing of things. And people who say it's a response to Ryzen, that's fine, but don't say it in a negative way. Oh, I can't believe Intel had to respond. Idiots, right? Like, that's what you want as a consumer. That's what you want AMD to respond to Intel's move now. And now you want Intel to respond to AMD's move. You want this back and forth. This is how you get better performance, higher clock speeds, lower power consumption, more options. This is competition doing what it's supposed to do. Would we have had 6-core Kaby Lake in the first week of October otherwise? I don't think so. Would we have had 18-core Skylake X parts available as early as we did? Nope, I don't think so, right? So that's what you're hoping to see. Let's see. We'll take these other two questions real quick. This one's from Anonymous. I heard you guys mention in a podcast with David Cantor, a very smart guy, that node shrinks don't lower the power usage to move data around, and that power reduction is a result of clever engineering somewhere else. Could you elaborate on that? How are the latest node shrinks affecting power or performance as compared to the older ones? I'm not exactly sure what you're trying to get at here. I tell you what, if you reply to this with a link to the comment that David made, I can answer it maybe a little bit better, or I can go to David and ask him. I have a feeling what you're saying, or what you heard from David, was that node shrinks don't lower the power required to move data on the chip, like from cache to cache or whatever it happens to be. And so node shrinks maybe don't improve that aspect of the CPU design, so it maybe wasn't relevant for whatever topic or subject we happen to be talking about there. In general, power reduction is a result of process technology combined with just better knowledge of that process and architectural design, right? So if you look at something like Maxwell, the NVIDIA GPU architecture, it was not on a new process node, I think. Yeah, not a new process node, but a brand new architecture, and they had huge improvements in performance per watt. So that's part of it. But then if you look at something like Polaris, which was a very, very similar architecture to what was previous to it, most of its reduction came from process technology. Most of its power reduction came from process technology, right? So there was still some of it. And that's something that vendors and chip designers are very apt to not want to talk about, is hey, our chip has lower power or better performance per watt. Okay, but did you do it, or did your process technology partner do it? Let's just say, it's a group effort, right? And that's kind of what you get when it's more on process technology. So, but if that's not the question you were asking, please give me a note, and I'll try to follow up with that. Last question comes from other Thomperson. Other Thomperson. What do you think about launching a side channel devoted to fishing? You could call it Ryan Trout. I don't fish, but you feel free to use that username in the chat on our podcast, I guess, going forward. That's it for this week's mailbag, everybody. Thanks for watching. Hope you found it interesting. If you did, like, subscribe, share, comment. I don't know, all the things that people tell you to do in other videos. But also, if you have a question, leave it in the comment section of this video on YouTube or in the comment section on PCPer.com, and we'll look through those, and maybe we'll answer your question next week. And it can be about a different show that's not a fishing show, maybe, or whatever it happens to be. So, all right, everybody. See you next week. Thanks, guys.